Hi everyone, welcome back to the channel. In this video, we are continuing our journey through the Kubernetes Certified Administrator topics. And today we are focusing on deployment rollouts. This is a really important concept, not only for the exam, but also for real-world Kubernetes troubleshooting. We'll cover what deployments are, how they interact with replica sets and pods, and the two update strategies that are rolling update and recreate. And we'll go through the key kubectl commands you need to know. Stick around until the end because I'll also explain a diagram that visually ties everything together. Let's get started. This topic falls under domain 3, workload and scheduling, which covers things like deployment rollouts, configuration maps and secrets, workload autoscaling, self-healing deployments, and port scheduling. Our focus today is deployment rollouts, so let's dive deeper into how they work. A deployment is highest level of abstraction in Kubernetes for running your application. It defines the desired state of your app. That includes the container image, the number of replicas, and the update strategy like rolling updates. Now here's the relationship. The deployment creates and manages a replica set. The replica set ensures that specified number of identical pods are running all the time. And each pod encapsulates your container along with the resources and rules that control how the container should run. When you update a deployment, Kubernetes actually creates a new replica set to reflect that changes. The old replica set is gradually scaled down while the new one is scaled up. There are actually two types of update strategies. The first one is rolling update, which is gradual and avoids downtime. And the second is recreate, which kills all the pods first and then recreates them. The most important commands you need to practice are kubectl create deployment, kubectl scale deployment, kubectl set image deployment, kubectl rollout undo deployment or rollout status. Now coming towards the live demo. In the live demo, we will create, we first check if there are any pods and deployment already there in the system, in the cluster. Now we will create a deployment with the image name of Nginx. Now let us see the deployment. Yes, the deployment has been created and now the pods are automatically created on the basis of the deployment. Now moving forward, using the kubectl scale deployment command, we increase the number of replicas, which increases the instances of our application. That is, it creates the number of pods. So we mentioned the 3 as replica set, and so 3 pods have been created. Now changing the image of our deployment from Nginx to HTTPD. And you can see now that image is also updated. Now we can also check the rollback history or rollback status. Now let us use the rollback undo, which will undo the image that we have just created. We changed the image to Nginx from Nginx to HTTPD. Now it is again reverted back to Nginx. Now the same command of kubectl describe can be used with deployment as well. You can see that deployment has been created and it has scaled accordingly. We can also use the kubectl logs command. Again, kubectl rollback history command. We have used it, and then we can also use the kubectl logs command to check the logs. In the end, we can delete the deployment through kubectl delete deployment command. It will automatically delete the associated pods as well. All right, that wraps up the deployment rollout in the Kubernetes. We covered what deployments are, how they manage replica sets and the pods, the two update strategies, and the key kubectl commands. We also walked through the diagram to really understand the relationship between these objects. If this video helped, make sure to hit the like button, subscribe to the channel, and share it with the Kubernetes study group. In the next video, we will move on to the configuration maps and secrets, which are another critical piece of Kubernetes workload management. Thanks for watching, and I'll see you in the next one. Thank you.